Okay, so we first open the map and we can use voice command to control the robot. Command start exploration. Command start exploration. Okay, now it starts exploration, the environment. And we can anytime use command stop exploration. Command stop exploration.
Yeah, I mean, I know.
Or use button to stop exploration. So now the robot has explored atmosphere and built a map of this room. We can also use the control panel to control the robot move. We can move the robot back to the origin point. So let's get it back to the origin point. Okay, and we can save the map. Just use the button or use command, voice command. Command finishing mapping. Now we have finished the first functions, mapping functions. We have built a map. We can load that map. And the map is here in the file, in the folder. You can see it. It's a PGM file. And we can also use.
Just now, you might migrate. Yes.
Sway. Okay, now we will demonstrate the second functions, root analysis, root analytics. So it's not, we use a greedy algorithm to analyze the root, and we can show that root here and in the folder. It's in the src sweep, src debug. We can see there are many files, and this one is the file we use. Here it's converted with the original one, and you can see many points and the root on this map.
Okay.
Okay. Now we can see the root.
It should not be off.
So you can see the root here, and we can finish analyzing. Now we can use our core functions, cleaning functions. We can load map, and we can use position set to allow the robot make a more precise position. And we will use AMCL to make sure the robot know where it is.
I love saving time, but I also want to make sure action issue.
Now the robot know where it is, and we can start cleaning. So in the cleaning model, there are three kinds of points: black, red, and gray. Black point means that is obstacle. And if the robot is cleaning, and if there is a moving obstacle, that point will be marked as black. And the red point means that point is a unvisited point that the robot needs to visit and clean. After the robot visits that point will convert it to green point, which means that point is clean. And I will show how to detect the moving people. I will not continue cleaning. At this point, I stand here will be pointed as a black point. You see on the map, it is marked as black. So if your cat or dog move in front of the cleaning robot, that point will be marked as black. And the robot will continue following that route to clean all the room until all the red points are turned into green. And we can stop it anytime, use voice command. Command stop cleaning. So this is just a very simple demo. And we can quit program. Okay, I will use this brief demonstration to introduce the codes, and actually the detailed codes explanations are already right in the README file, includes the modules, the development ideas, and the core algorithms. For example, here, what algorithms are essential in this program, and what packages were used, what technologies were used. And so in this brief demo, I will basically introduce our project directories and select some very important part to introduce. So firstly is that directory. There are 5 folders. Include map is 6 folders. The maps stores the maps that are saved. Here you can see the maps. They are saved in 2 files. And in the folders, there are 5. And the first one is cleaning board, which is the explore light package files. And we have modified some parameters. And this is supporting for the building map and mapping functions. The next one is the simulation world. There are 3 simulation maps that in Gazebo we test our robots, mainly in the Explore Light package, and what we based on that package to develop our frontier exploration strategies. And the Turtlebot 3 is that we build our own Turtlebot, and you can see we use our this is virtual machine that run Ubuntu 20.04, and run the ROS Noetic is similar as the lab, the robotics lab, and I'm considering to update into ROS to have the discourse. And next one is the control panel, which is very important here because it is the panel that we can see that in the real demonstration, we use that panel to click some buttons and use a voice command. So here we use this tkind, and it's just like front development. And it's just like draw a website, very similar. And for example, open map is that button, right? And when you click it, you are just actually start the function that here is start slam, which means start slam. And you can see that in the start slam function, it is publishing a message that the topic is published in gmapping pub. And you can see it in the very first beginning that gmapping pub is published in control gmapping topic. And you can see another controller node, which is called gmapping controller. Use the control gmapping topic to receive that message. For example, if you receive the start gmapping, you will run the function start gmapping. Then you will use this to start. It's just like to open a new terminal and input the Linux commands that ROS launch, blah, 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 and to run that file. So why we need these controllers? Because in our program, we need to build a map and use the map to localize. You cannot run SLAM and AMCL at the same time. So you need to control the open and close of the SLAM. On the other hand, once you have built the map, you do not need to, if you don't change the rule, you don't modify very greatly, you don't need to build a map again. So the mapping function, mapping model is separately. And once you're done, you don't need to open it again, right? And the voice VOSC here is VOSC, we use VOSC model to, you can see here, this file is the VOSC model files and it's offline recognized. So this command use voice commands topic to publish the strings. Actually, the words is strings that are recognized and published in this topic. So in control GUI, I use a callback function which calls the voice callback. Just listen to that topic and to recognize the words. Use very simple if-else structures. And I have accent, right? I have accent. So when I say something like command start exploration, it's sometimes recognized as commander because I use the commander start exploration. So I use different similar words to increase the recognition precision and precise, make it more precise. And I use multiple words because I don't want sometimes when I have this demonstration and introduce the start exploration button, and just hear the start exploration and start exploration. So I need to add a command before the words because it's a callback function, right? It will always listen what you have said. So this is the control panel. And another very important is the sweep, which is the most important part here because we write all these 4 scripts to analyze the route and make the robot follow that route. So firstly, this route map server is to make sure that the foundation nodes are running. For example, the map server node, the MCL, also the RVs. And once you have opened all of these foundation nodes, you can use route plan to analyze the route. And after this analytics, there will be a path file produced. Once you got that path file, you can use route follow to follow that path. And you can also use route show to show that path in our feed to see if this is good or not. And you can refresh it, reanalyze, and reproduce it. So I think the most important part here in our program is route follow because this is actually the function of cleaning the floor, right? So once the map is analyzed, the map will actually convert it into an array, actually, essentially. And that array will contain 3 kinds of values, which is -1, 0, and 1. And in that path file, there will only be -1 and 0 so far because so far this program will only consider to mark a point converted into green when the program is running. And if you turn off the program, the point status will be lost because they are only stored in memory. And in the future, I might consider, actually I have tried to store the status to achieve the function that, for example, you want to clean the room twice a day, and in the morning it clean half a room, this half. In the afternoon, it will clean another half. So the status can be stored. But now, so far, I deleted that part because now we test in very we want to test the route analysis. We want to optimize it. So that part is not very hard. But the most hard point is to find a route and to make sure the robot is following that route. So once we got the points, we can use that points to find the route. How to find the route? Here, build path connections. And we can use the points in converted from the map, and we already use RVs and MCL to find the let the robot know where it is, right? So the robot know its position. Then the robot will know which point is that robot nearest. So that point will be the starting point. The robot will follow that point, start the route on that point, and access the points one by one. Once the robot reach one red point, that red point will convert it into green point. And you can always see this in previous demo or the README file. And during it, we have this function is point reachable, which is also very essential because it is to check the point. It's Chinese, but I forgot to convert it into English. My mother language is Chinese, and sometimes I use Chinese much faster, thinking faster. And this sentence means to check the point is reachable. So if the robot want to follow that route, right, and there is a next point the robot want to reach and find a person is standing, an obstacle, a moving obstacle is there. Maybe a pet, maybe a cat, maybe a dog. That point will be considered as unreachable when the program is running. So in that case, the robot will consider another point and mark that point into black. So the robot will find another nearest point. This is the next point, and this is the nearest point. So there are many functions here. Actually, at the beginning, I have just read about 50 lines, want the robot to follow that line, but there are some bugs. For example, if there is an obstacle, the robot will confused. And so I add this function that the find nearest accessible point, and so the functions became more and more, and last it became like about 566 lines. So now the demonstration is very good, but there are too many lines, and I will optimize it after the final demonstration. And you can always find the detailed of these two essential scripts. One is the route plan, another one is route follow here. And now the program is not perfect because in the route plan and route follow, there are similar parts and they can actually write in one file. So I will optimize them later. And this course is really interesting. And this will be the last demo. And I will want to add some special thanks to the Professor Peter Salas, very interesting course. And also thanks to the teammates and there's some classmates that we have discussed about some, like the other topics may be very interesting. And this course is very interesting also. So the demo is here. Thank you.